Hello everyone, welcome to my YouTube channel. Let's learn with Dr. MG. This is Dr. Moumita Ghosh, Assistant Professor from SR University, Warangal. Today I am gonna discuss one important topic of probability and statistics, which is conditional probability. Before I start the formal definition, here I will explain why conditional probability is important. First of all, it's not just a math topic, it's a way of thinking. Conditional probability teaches you how you should upgrade your decision once a new information is available to you. Suppose you are working on analyzing system failure or debugging a code, you will update your decision when new information becomes available. Let me explain you with a simple story. Suppose exam session is going on and you are coming to library to study. So you walk into the college library during exam session and you are looking for someone who is very serious, and the library is packed during exam session. You pick any random student and your thinking will be like, what is the probability that student is serious? Then you notice a group of students sitting in the reference section. There are a lot of textbook and notes are scattered in their table, and they are very serious with their notes and textbook. Now your thinking pattern is changing. So now you think, what is the probability that they are serious given that they are in the reference section? So you are not thinking about all the students in the library. Your thinking is very focused in your reference section now. So your thinking has changed as you have got some extra information, and that's what is conditional probability. Updating your odds with new information. So here comes the formal definition of conditional probability. Probability that the event A will occur given that the event B has already occurred. So in mathematically, we will write this way. Probability of A given by B. And here is the formula, probability of A intersection B divided by probability of B. And the most important thing is probability of B should be uh, not equal to 0. Now, now you know the formula of conditional probability. Let's start with one example. A standard deck of 52 playing cards is well shuffled. A player randomly draws one card from the deck, and event A means the card is a king card, and event B means the card is a red card. And you already know there are four sets of cards. 13 cards for spade, 13 cards for club, 13 cards for hearts, and 13 cards for diamond. Each section will carry one king, one queen, and among them, hearts and diamonds are red, spade and club are black. Now the question is, if a player already knows that the card is red, what is the probability that the card is king? So you have to find out what is the probability that the card is a king card given by the card is a red. So please ignore my handwriting. Okay, let's solve step by step. Total number of red cards are 26, 13 diamond and 13 hearts. Total number of king cards are 4. One spade king, one diamond king, one club king, one heart king. And number of king card as well as red, that is 2. One diamond king and one heart king. Now, you know what is the probability of red card. Probability of red card means number of outcome favorable to A, that is 26, divided by total number of points in the sample space, that is 52 number of cards, which is half. Then you calculate the probability that the card is red as well as king, red and king. So it's 2 by 52. Next, you will calculate the probability that the card is king, given that you already know the card is red. Here it comes the formula of the conditional probability, and you got the answer. Makes sense? Let's solve this problem. In a lifestyle survey conducted in a city, 70% of the people drink coffee. That is my event B. Among those who drink coffee, 50% also like to eat cookies. So this is my event A given by B. I am talking about the percentage who like to eat cookies given that they already drink coffee. Based on this information, now the question is what percentage of the total population likes both cookies and coffees? So you have to calculate the probability of cookies intersection coffee. So let's solve step by step. I have to calculate this thing, probability of coffee intersection cookies. And I will use this same formula, probability of like cookies given that they already drink coffee into probability of drinking coffee. So next thing, I already have this 0.5 people who like to eat cookies given that they already drink coffee and probability that people drink coffee. So here comes the answer. Okay. Next problem. A family has two children. What is the conditional probability that both are boys? Given that at least one of them is a boy. Now the sample space we will like boy, boy, first child boy, second child girl, the converse, and both are girls. So the question is I have to calculate what is the probability that both are boy. First baby boy, second baby also boy, given that at least one boy. And now at least one boy means it can be boy girl, girl boy, and boy boy. Now you know the answer. Still, I will explain in the next slide. So if I use the formula, first thing I will find what is the probability of A intersection B, which means both children are boys and at least one child is boy. So there comes only one intersection point, boy boy, and it's 1 by 4. Then I will calculate the probability of B, that is at least one boy. Both are boys, first baby boy, second baby boy. So directly it will be 3 by 4. And here is the final step by using formula. You can also solve this way like how many points favorable to the event A, that is both are boys, 1 point, and how many points favorable to the event B, that is at least one boy, 3 points. So it's also 1 by 3, same answer. In the next video, I will discuss this definition. What is the definition of independent event? Till now, let me know if you have any suggestion for me because this is my first video on YouTube. Thank you everyone.